If we were talking about bacteria, which reproduce every 20 minutes, still not enough time in our short lab period. So what we're going to do is we're going to model. We're going to do a model of evolution. And scientists use models all the time when they can't do manipulative experiments. And so what the model that you guys are going to do, we're going to have a population of these fictitious mice, okay? So if you look at the supplies on your table, you see that you have some, you have some petri dishes of different colors of these fictitious mice. So these represent the mice, and the colors represent the coat color. So this is variation within the population for coat color, and this is genetic, okay? So it's passed on. So what does that mean? Red colored mice have red colored babies, okay? Orange mice have orange colored babies, okay? So they pass it on. That's inheritable, okay? And this is, everybody has a different habitat. Your cloth is your habitat, okay? That these mice live in, all right? And so I also have a handout for you. The handout is to help you keep track of 3 generations of these mice. So what you're going to do is you're going to start off with a population of 100 mice, okay? So you're going to count out 10 of each color, and then you're going to sprinkle them, okay? So if I were, let's say I have 10 here, and you're going to sprinkle them throughout your population, okay? All right. So we're going to sprinkle them throughout the population. So you'll have 100 mice, 10 of each color, at the start in your habitat here, okay? Now we have to introduce some limits to reproductive success. And the limit to reproductive success that we're going to model is predation, okay? So 3 of you at your table are going to be predators, okay? You're a predator, you're a bird, and this is your food source, okay? But you're only strong enough to capture one mouse at a time, so 1 chip at a time, and you have to bring that back to your nest where your babies are hungry and need food, okay? So your hand is going to be your nest. And so you can only pick up 1 mouse at a time. You can only hunt and pick up 1 at a time, okay? And so 3 of you are going to be the predators flying over this habitat looking for food for your babies, okay? And so during the hunting cycle, you are going to hunt 25, okay? So 25, you're going to want to get 25. So 3 of you are hunting, so that's 75 mice that are going to be eaten, okay? And then we're going to record the survivors on your chart. So if we hunted 75, we started off with 100, there should be 25 left, okay? So we're going to, and then I'll give you some more instructions after we get our first hunting done. So you let them get their stuff, okay, sprinkle it out. And then you go, okay, on my signal, decide who's going to be the 3 hunters, and then the 4th person, we're going to make you in charge of, managing the dead, because we are going to have to recycle some of these chips, okay? So the person not hunting, and you can take turns each round, will need to start sorting the chips by color, because we will need to reuse some of them throughout the model. So on my signal, start to hunt, okay? And so wait till my signal, okay? And so are you guys ready? Everybody ready? And say ready, set, okay, hunt, and turn the lights off, okay? And when you turn the lights off, I go, oh yeah, I forgot to tell you, you guys are nocturnal. You hunt at night, okay? Because their eyes will need to adjust. And there is a safety light in here, so when you do turn the lights off, you see that there's 1 light back there. So it'll take them a second for their eyes to adjust, but that's plenty of light. And so they hunt, and then you turn the lights back on when they're done hunting. And we need to record our survivors on our data table. So they need to list the colors on that data table. And, I put the data table in there. Yeah, so here's the data table. And so they're going to need to list the colors, okay, here, the mice. They had 10 at the beginning of each color. Now they need to record the mice eaten and then the mice that survived, okay? So the mice that survived now have babies going into the next generation. So if there were three orange mice that survived, then they need to add 15 more orange dots. And then if there were 2 pink ones, they need to add 6 more, so that they reestablish a population of 100. Okay. Then we hunt a second time. So we do the process again. Okay, and they usually get better after the second time. And then we record the results again. And then we hunt a third time. Okay. And then after the third hunting round, then graph your results on the board. And when you graph your results on the board, just make a little bar graph. Put your colors of mice on the bottom and your number of survivors on the side, and tape your habitat under your graph. Okay, so we'll do all that on the back board. Okay, so back here, they should have, they tape up their habitats, and then they record their results. So they have their graph, and they list the colors, and the colors. And so once the 6, and then, do bar graphs, boop, 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 green, maybe this is white, maybe this is brown, okay? But they do list all the colors. And so red, I don't know, orange, pink, purple, And so if it's 0, they can just, put a line like that. And number of survivors, then maybe there's like, by the end, 75 green, okay? So they have these bars, okay? And what we do is we ask them, okay, so what do you think? What can you tell me based on these results that we're getting? And hopefully they're going to see that, oh, well, obviously the mice that are fictitious dots are mice that blended in with their environment are the ones that survived and passed on those genes, and so that's why we have that many surviving and some of them dying off. Okay, so then we ask, okay, well, does this support Darwin's theory of evolution by natural selection? And so hopefully they're going to say, oh, yes, it seems to support it. Okay, all right, so that's our basic model there.